This is problem number 8 from section 5.4. It says a pot of boiling water with a temperature of 100 degrees Celsius is set in a room with a temperature of 20 degrees Celsius. The temperature T of the water after X hours is given by this equation. So we know that T is the temp and X is the hours. And they give you this function. Estimate the temperature of the water after 4 hours. So for part A, they want us to just plug in 4 and for X. So let's do that. That's T of X equals 20 plus 80 e to the negative X. But in our case, e to the negative, and I should have put a 4 there. T of 4, my bad. So e to the negative 4, because that's what we're doing for the input is 4 hours. So we'll plug all that in, see what we get. 20 plus 80 e to the negative 4. 21.5 we'll round to. So 21.5, and that's 21.5, that's the temperature, so that's degrees Celsius. Part B, how long did it take the water to cool to 60 degrees Celsius? So let's go ahead and put in now 60 degrees, but we're putting it in for T of X. So we're going to say 60 equals 20 plus 80 e to the negative X. And then we need to solve for X, so we need to isolate e to the negative X. So I'm going to subtract 20 to start. That's 40 equals 80 e to the negative X. Now I'm going to divide by 80. And I get 1/2 equals e to the negative X. Now I need to cancel this exponential. That's base e, so I'm going to use natural log on each side. So natural log, and I'm actually going to bring in the log laws here. One of the log laws I'm about to use is log base b of b equals 1. That's exactly what I'm using here. This is base e, right? So I'm just going to use the exact same base to cancel it. So natural log 1/2 equals natural log e to the negative x. But I'm also using this log law, which is if I take log base b of of any number raised to a power, that power can come out front. So negative x is going to come to the front. So I get natural log of 1/2 equals negative x, and I'll say times natural log e. Natural log e, right here, log base b of the same thing is 1. So that cancels out, and I'm left with natural log of 1/2 equals negative x. Last step is to divide by negative, so I end up with negative natural log of 1/2 equals x, which equals, if we plug that in the calculator, we get negative natural log 0.5, 0.69. So in order for it to cool to 60 degrees from 100, so I would say from 100 degrees Celsius to 60 degrees Celsius, it takes, well, 0.69 hours, which is like, I don't know, 40 minutes. And that's the solution.